Hey everyone, welcome, and thank you all for joining me. I'm Aaron Chavez, and I'm a creative technologist, a part of the Xbox research and design team. We're the team generally responsible for designing and evaluating player experiences across all of our products. I work mainly as a designer on things related to player input. For over the past 4 years, that's primarily had me focus on designing and building the system of touch controls we use to make Xbox games playable today on mobile devices without using a controller. So, before we jump in, I just wanted to give a quick shout out to the teams at Mojang, Supergiant, the Coalition, and Rare, whose amazing work can be seen throughout all this presentation. So, why do we even have touch controls in the first place? For us, this focus first started back in 2017, when this message here became our mission statement. Play the games you want, with the people you want, anywhere you want. Back then, plans for cloud and the series consoles were really just starting to come together about this time. And as a design team, we started to think about how and what, anywhere would mean for our games. And as we looked toward what a cloud experience would be like in, say, 2022, it didn't take long for us to realize we had a gap in our capabilities as a platform. Anywhere doesn't mean anywhere you have a controller, because let's be real, not everyone's carrying around a controller with them at all times. Anywhere means anywhere you have a screen accessible. We love this image here because it reflects one of the biggest experience opportunities we have today. We know from research that half of all mobile gaming happens within the home. In fact, we're seeing that 1 in 5 players use touch controls exclusively on cloud. Not only that, games that add touch controls to their game are also seeing a 2 to 5 times increase in gameplay time. So, before we get into too much detail, I'll first play a quick video from our marketing team, which shows a montage of the touch controls in action. After that, we'll dive a little deeper into exactly how the system works. All right, so what you saw there were a number of different examples. Currently, we have over 130 games available to play on the service. If you haven't had a chance to play with it yourself yet, I highly recommend it, and it's super easy to do at xbox.com/play. With Touch on Cloud, from a technical standpoint, it's important to understand that there are really 2 main UI technologies at play here. And these are not exclusive. They can be used interchangeably with one another, just as Minecraft Dungeons has done in their game. First, we have native touch, shown here on the left. Here, the player's touch interactions are processed directly by the game as native Windows Touch events, and all visuals are rendered in Engine. This type of system works perfect for less game-critical moments such as menus and inventory management. In Minecraft Dungeons, they use native touch to pinch and pan on the map, and they also use it so that you can touch directly on the buttons in their UI. In contrast to this system, we have touch adaptation, which instead renders directly on the client device and sends a mixture of keyboard, mouse, and controller data to the game. These controls don't need to wait for the game to render in the cloud, and instead visually respond immediately to touches. What we discovered in early usability sessions was having super responsive controls like this greatly aided players in scenarios where accuracy was needed, and it increased their perceived sense of control over the game. You can more or less think of this system as being somewhat analogous to our physical controller, and it's best used to control things that require more timing-sensitive precision, like character look and movement. For the rest of this deck, I'll mainly be focusing on touch adaptation. So, stepping back again to 2017, this was the brief we set for ourselves. Console-first games are fun to play on mobile devices. This process started with many different usability sessions and a lot of different control experiments. This year was our starting point. We asked ourselves, hey, why don't we just put all of the buttons from the controller on screen? It's familiar, everything's there, why not this? Well, when we brought this to the user research lab, it ended up performing quite poorly. We tested it using a popular open world game, which on its own is excellent and sees quite high user sentiment ratings when played using a controller. FunScore here is based on a basic 1 through 5 average user rating that we've been using internally since the original Xbox. We've used it to try and predict how well a title will do once it goes to retail. Now, it isn't comprehensive enough to predict if a game will be a success, but we have data that shows that anything that scores less than a 4.2 will very likely not be. Yeah, the game we chose was probably a bit of a hard game to run this at, but with a score of 2.1, which is half of 4.2, this score is actually in the range of making people angry. Players often felt that the layout felt familiar, but there were a lot of simple tasks they could not do. Driving a vehicle, for example, requires you to steer with your left thumb and accelerate with RT, which is manageable. But if they needed to reverse the vehicle, however, they would either have to resort to using claw or reach across the screen with their right hand to press the LT button on the left side of the screen. As we move deeper into the problem space, it really starts here. Games are designed around input, and all of the games in our catalog were designed to be played using 2 fingers and 2 thumbs, and some of which requiring analog precision and the thumbsticks and triggers. Comfortably holding a phone, we only ever really have 2 thumbs accessible without resorting to alternate stances like claw. This means we need to be creative where we can and overload actions that require more than 2 fingers to execute. After the basic layout prototype, we ran several more research studies over the following year to try to learn as much as we could about the mobile space and what would it take to give players a fun gaming experience without a controller. We built a lot of different prototypes during this time to explore different ideas, and when we thought we had something with substance, we'd take it to the user research lab where we'd run play tests where 25 or more people would come in and give us feedback. From there, we'd identify areas in games that people had difficulties with, figure out what worked and what didn't, and then we'd refine our design and regularly repeat this cycle, almost every couple weeks. Fun is an exceptionally high bar, and at the end of the day, we've landed on these 7 main key takeaways from mobile. At the top here, we have a group of things that we think can mostly be solved for by the platform. The first point, finger input is missing, basically means that players expect to be able to play games on their mobile devices without a controller. Convenience is a major draw for mobile gaming, and carrying a controller around simply isn't convenient. On the next point, we have customization is required for playability. This refers to 2 things, really. First, rather than use a generic layout, touch controls should be purpose-built per in-game scenario. The only controls on screen at any given time should be controls that are usable in that moment, giving every bit as much screen real estate as we can back to the stream. Going back to the open world example from earlier, this would mean using one set of touch controls while running around on foot, and a different set of touch controls for driving vehicles with the buttons positioned, optimized for each scenario. So you would have both gas and accelerate on the right hand for the driving layout. Second, the user needs to be able to adjust their controls to be placed in a position ergonomically optimal for them. I'll talk a little bit more about this in a later slide. The third point we have in this category is latency affects responsiveness and accuracy. Now, latency might not be something we can eliminate entirely, but continual improvements to our service and client-rendered controls help mitigate this. Moving on to the next section, we have a group of things that we also think are solvable, but the solutions require some more work from the game side. Starting with small text on phone screens. This means make sure your text and UI remain legible on small screen devices. To help with this, we provide hooks in our CloudAware SDK, a part of GDK, that will allow the game to detect the physical size of the stream, so responsive UI can be built to handle the high variability of screen sizes across the market. Next, thumbs will occlude your stream. This means be careful when placing important interactions or visual cues under where the player's thumbs want to sit. Some platforming games, for example, that don't center the camera around the player's avatar can be especially challenging to play if the character needs to run under where you have your thumb placed, for example. Objective tests and health bars and whatnot also are usually better placed towards the center of the screen rather than the left or right side where it might sit underneath the player's thumbs. The next point, semantic icons are expected, prevents a unique accessibility opportunity for touch. Since we can draw any graphic we want on mobile and don't need to manufacture buttons ahead of time, we don't need to rely on abstractions like A, B, X, Y, LT, RT, LB, RB to tell a player how to play a game. Instead, we can simply display an icon that represents the action taking place in game. Rather than putting an A button on screen, for example, we can put a jump icon. Rather than labeling a button LT, we can instead display an aim icon. This is super powerful because it gives controls the ability to be visually self-descriptive, and it's something our physical controller can't do. And finally, last but not least, every modern phone has a built-in gyroscope. This presents an exciting new opportunity and becomes pretty critical to make first and third-person camera-controlled games feel native on mobile. When people first start thinking about adding touch to their games, they usually think of it as a lowest common denominator or the most basic form of input. Gyro, however, brings a very mouse-like method of precise aim to the experience and is much preferred over using something like a virtual right-scheme joystick to control character look. It takes some time getting used to, but it's really the magic component that enables a high skill ceiling on touch. Many players find that they are more accurate aiming with gyro using touch controls than they are aiming with the right joystick, because all you're really doing is using your phone like a window to point where you want to aim. So, now that we've covered some of the fundamentals, we can now talk about how the layout system works. Per the recommendation of Edie Adams, one of the original designers of the Xbox controller and as our chief ergonomist here at Microsoft, we based our framework off of the same ergonomic arcs and principles that we use with our physical controller. The green arcs here represent where users can comfortably move their thumbs, with the bright green color being the most comfortable zone. You'll notice as you sweep your thumbs around, as they hit they hit the extent towards the center where it becomes more comfortable to instead pivot. When building touch layouts for your game, a good place to start is by making sure your most important actions don't stray too far away from this zone. We'll often hear people say, hey, touch controls don't work for me because I can't feel where the buttons are. But what we found in the lab is, if you can get the controls to sit in a neutral position with the thumbs resting over the center control without any extra reach, users have very little issue hitting their intended buttons accurately. Our system allows players to enter this sort of ergo edit mode, pictured here, where you can reposition, rotate, and resize the controls quickly grabbing onto these two sort of big wheels, which are basically just large groups of controls, one for each hand. This diagram here shows the basic layout template available for games to use. Controls can be added to any of the slots you see here in the top right corner, bottom center area, or either of the two big wheels that players are free to move and resize. We've reserved the top left corner for system-related actions, and it's there that you'll find buttons to use to navigate the platform. You'll find the Xbox button there, and you'll find a button that button to basically edit the ergonomics of your control layout as a player. The beauty of this system is it enables us to scale to any combination of screens and hand sizes. As a platform, we're basically able to handle cross-device compatibility for developers and automatically support things like dual screen displays as they become available. We really try to strike a balance here between doing what we can to set players up for success and giving developers a consistent and expressive set of tools to work with. When working with our tools, developers are able to configure their controls in a JSON format, save their changes, and then view and play them in real time for a super fast iteration loop. Now, for this next segment, I'm going to show you a few different game examples and walk through each of them in a little bit more detail. I'll start by showing you Hades as a simple example, and afterward move on to Sea of Thieves and Gears 5, which add a bit more complexity. So first, we have Hades. Now, I'm a huge fan of this game. I first played through it a couple of years ago when it was released on Switch. And with the release on Game Pass on Xbox, I played through it again, but this time around entirely using touch controls. Here's a clip from the learning encounter from one of my Pack the Punishment runs with the Adamant Rail. Being a lift and shift title, the developer did not need to adjust any code to make this work. But the first thing you'll probably notice about it is they use custom art. This really goes a long way for making a touch game feel more polished and in the style of the game and takes very little effort. They kept the layout overall pretty simple here, mostly just rearranging the controls to play better using only two thumbs. On the right hand, they've really optimized the layout around being able to hit A, X, and Y easily. That's dash, melee, and special attack. If you can picture those green arcs I showed you earlier, you can see the placement of these falls right in that comfortable swiping range here. B, which controls cast, is strategically placed centrally adjacent to these three controls to combo nicely between any of these actions. Next, we have the right stick click, which is used to reload the rail weapon, as you see me using against this fight right here. Now, the left-hand joystick here is a little bit more unique. Most of the touch games in our catalog that have left joystick use what we call a relative movement. That is, the center of the joystick is defined by where the player first places their finger during their interaction. This most behaves like our physical controller in that you must swipe your finger in order to set the direction of the control. So this has the advantage of translating nicely for players that are already familiar with our controller. With the Hades touch controls, however, they've instead used an absolute joystick, which is defined by being centered around a fixed position. Interactively, this behaves much more like a 360-degree D-pad and is a pretty unique mobile interaction. The fixed position allows the player to better develop muscle memory based on where they anchor their hand on the device once they've dialed in their ergo settings, making for a much snappier character locomotion. So moving on, next we have Sea of Thieves. I'll start by playing this video all the way through, then go back over a few things that are happening along the way. You'll notice we don't have a joystick on the right-hand side, and instead have a slightly opaque area with a faint eyeball in it. This is what we call touchpad control, which tracks your finger across the screen, much like using a mouse on PC. This type of control is strongly preferred for camera control over using a virtual joystick on touch. With the physical controller, you're able to feel the edges of the control boundary as you push your finger against it, and a constant opposing tension pulling and guiding your finger back towards the center. Once your finger's down on touch screen, however, and you slide it around, it's impossible to find center again by feeling. It's worth pointing out also that jump, fire, and interact are all actually configured as touchpad controls, so the player can look around while using any of those controls as well. Fire is in a very deliberately placed position away from the edge of the screen so that the player has plenty of room to spin their character to the right if they need to fire, if they need to turn their character and fire while turning. So going back now, one of the first things you saw me do in this video was press the aim down sights button, which is configured as a toggle. This basically means it activates on press, and instead of activating on release, it needs to be pressed again to be deactivated. So the button in a way becomes sticky. Like many first-person titles, it's important to be able to move your character, point the camera, aim down sights, and fire all at the same time. We only really have one way to solve this problem on touch, but the solution is surprisingly effective. When the ADS button is activated here, it holds the left trigger down for us until we toggle it off. In this layout, it also turns on the gyro, which eliminates the need for us to use the touchpad to aim before taking our shot. Conceptually, you can think of how touchpad and gyro work together as the touchpad being like turning your body with gross control, and the gyro being more like turning your head with fine control, but in a fixed, limited range. You really use the gyro to get that last little bit of mouse-like precision. So all that being said, with the gyro activated, we don't need to use the touchpad to aim. The right thumb could instead focus on the fire button, while the left thumb can focus on character locomotion. Moving on, you may have noticed that we have 4 different joysticks all on the left hand. The chat, emote, and inventory joysticks on the top and bottom all work great to control the game's various radial menus. In the example here, I press this little joystick with the backpack icon on it to open up the inventory. This is basically just a joystick that also presses the right bumper down for us on touch start. The character locomotion joystick in the center is configured a little bit different than this. To sprint in Sea of Thieves, you must first be moving forward, then stick click to the left joystick to enter sprint. To avoid adding a dedicated sprint button on the layout to the right-hand side, we added an action for this joystick that activates once the user presses forward a bit past the extent of the joystick, instead of immediately on touch. So, as you can see, by using tricks like these to overload multiple actions into single controls, we can make first and third person games more playable with touch. Lastly, we have Gears 5. You'll notice it has a pretty similar setup here to Sea of Thieves, where we have a touchpad on the right-hand side with a toggle ADS button and fire position in exactly the same spot. Being a more intense shooting game than Sea of Thieves, they have gyro set in the layout to always be on instead of activating only while aiming. They did something really clever here with their fire button. It actually acts as both a fire and ADS button. In addition, then they also made it lock on target during ADS on the default game difficulty and turned off weapon recoil in single player because of the effect it has on gyro. Basically, recoil doesn't play very well with gyro because it forces you to continually rotate your phone down to compensate for the camera shift, quickly putting you into an uncomfortable position that you have to sort of swipe up to correct. While being a CloudWire game, they aren't using native touch for their menus, but they do switch to a different layout while using it. And they use about 12 different other layouts to display, depending on whether you're playing single player, multiplayer, driving the skiff, stomping around in a silverback, or controlling Jack. They also integrated our latency erasure API for active reload. Active reload gives the player a small but precise timing window to press reload for added damage bonus in the game. By the time the player sees the white bar line up visually in their client, the server is already some milliseconds past this, and will still need to wait for the input signal received from the client back to the game. Latency erasure allows the game to reconcile input frames based on what the player was actually seeing on their screen at the time that they pressed the button. So the game can sort of go back in time and verify, yes, this is what they were seeing when they pressed the button, and then give the player their damage bonus. So this last feature I'll talk about here was easy to miss in the video, so I'll go back and play just this part. They implemented a feature we call layer shifting on their weapon button on the left hand. Layer shifting is an experimental feature, but it basically allows you to temporarily shift to another layout without doing a cloud-aware call to change the layout. When you press the weapon select button, it hides the other controls and puts the D-pad in the primary slot on the right hand for weapon select. Not many games have taken advantage of this yet, as it can certainly add to cognitive load if not used carefully. Scarlet Nexus, I believe, is the only other title in our catalog that currently is using this, where they use the show and hide controls to skip in cinematics, basically. So those are just a few of the examples of games, but there are a lot more for you to try out for yourselves on Game Pass. If you have a game in active development that you'd like to try adding touch controls to, or you've already shipped, I encourage you to take a look through the catalog and see how other games with similar control schemes may have already implemented touch as a way of starting some ideas. It's as simple as pointing your browser to xbox.com/play on your desktop or mobile device and signing into your Xbox account. So thank you all for listening, and I look forward to seeing what you come up with.